Hello folks, this is your 2020 October November paper 1-2 and the question number is 31. The question is concerned with the chapter electric field as is shown by the diagram there. It says that a molecule behaves as an electric dipole. So dipole means two poles. It says that a molecule has two poles. It's because when we apply certain electric field in a molecule, it's positive and negative reorient. And because of that, in one part there will be high degree of electrons, high concentration of electrons like this, and in the other part the nucleus is supposed to cram up. So that's why this appears as positive, this appears as negative. So that whole entity is called as a dipole, consisting of two equal point charges of opposite sign, so plus and minus. So this end acts like minus and this end acts like positive. So you can see here also separated by a fixed distance, so distance here. The molecule moves with a constant horizontal velocity as it enters a vertical uniform electric field. So the electric field is vertical, which means this side is positive and this side is negative, and this thing is moving horizontally like this as shown. The positive and negative charges of the molecule enter the field at the same time. So they enter the field at the same time. It is not the positive first or the negative first. What describes the effect of the electric field on the velocity of the molecule? So we have to find the effect of this electric field on the velocity. So what happens here is the electric field is vertical if you look from this view. So it does not affect any horizontal motion. This vertical field will not affect any horizontal motion of the body. So that's why the horizontal velocity should be constant. So if this is horizontal, this velocity should not change. That's why the horizontal velocity should be constant. So if I go to choices, choice number C and D, they disqualify, only A and B remains. Now with this application of field, what happens is this plus charge will feel a force in this direction, plus charge, and the minus charge will be feeling a force in this direction. It's because plus will be repelled by this and attracted by this, so force here. Minus will be attracted by this and repelled by this, so force here. So what might happen is the molecule might elongate slightly. The molecule might elongate slightly here, slightly. This will be minus and this will be plus. So the overall force, vertical force, will be again 0. The overall vertical force will be 0. It's because there is some force here also, equal force here also. So the overall force should be 0. And this comes from the equation F is equal to QV by D. So V is same here, no change. The distance of the plates here will be also same. And the charge also, the magnitude of this negative and this positive is same. So force is same. So that's why this force and this force is same, which makes the resultant 0. FRES is equal to 0 on the whole dipole. So that's why the vertical velocity here will be, initially it was 0. Now since this is 0, it does not, the vertical velocity does not change. This thing should not change because F resultant vertically is equal to 0. So if FR is equal to 0, A resultant is equal to 0, and this V vertical should remain. This vertical should remain constant. So I say constant, but wrote to change here. This V vertical should be constant. So constant at 0. Initially it was 0. Only horizontal was there, vertical was 0. So it is constant at 0. So this gives us choice number. Choice number B is the correct choice, and A also is incorrect. So when our dipole moves, their horizontal and vertical velocities are unchanged. So since we have got the vertical velocity is initially 0, it remains unchanged at 0, So that's why the velocity also remains 0. So this is the answer to the question.